All right, so we're going to be taking a look at scale factors and how they kind of affect area and volume, and kind of what we do with area and volume based on those factors. So first of all, I've given you a whole bunch of area formulas. Some are what we probably would know. Other ones maybe are a little bit different, or ones that we may not kind of recognize right off the bat. But if you want to use any of these area formulas, you can. You will not be required to use any of these formulas. They are just there for your reference as of now. So the area of many shapes are given in the table. If a formula is needed, it will always be given. Let's look at now how we deal with the scale factor when we deal with area. And so we're going to start off by drawing a rectangle. And I'm going to draw a rectangle that is 3 by 4. Okay, so I'm going to draw a rectangle. It's 3 by 4. So this is 4, this is 3. It has an area of 12 square units, right? So we can kind of see it on here. It's 12 square units. I'll just shade it in the rectangle there so that you can see what it looks like. Okay, there we go, and that's 12 square units. Now let's take this same rectangle and let's double it. Now, when we say double it, there's a whole bunch of different things we could do. We could double the lengths, we could double the area, and you'd think maybe it would be the same thing, right? But let's double the lengths, okay? So we're gonna double this, so we're gonna have a length here of 6. So that's 1, 2, 3, 4, 5, 6. And this is gonna have a length of 8. Okay, there we go. So that is 6 by 8. Now, when we double the lengths, okay, and this is what we mean when we say we're going to double it. If we're not told what to double, we just always double the lengths. When we double the lengths, we get now an area of 6 times 8 is 48 square units. And again, I'm just going to quickly shade this in so you can see that area. It's a little tough on the video sometimes to see. That's 48 square units. Now, when we double the lengths, what happens to the area? Okay, so that's one thing we want to kind of see. What happens to the area? Well, the area, what we're going to do here is our scale area over our actual area is now 4 times bigger. Okay? And if it helps to kind of see, if I draw in, here is 3 by 4 rectangles, you'll notice there are 4 3 by 4 rectangles. We can put this rectangle in here 4 times. We double the lengths, meaning that the area is now 4 times bigger. Okay, it's 4 times bigger. Now what happens if we triple all of our dimensions? And I think I might have enough room on here to triple. Okay, if we triple, that would be a 9 by 4, 8, 1, 2, 3, 4, 5, 6, 7, 8, and then 12. Okay, it's a 9 by 12. So this is a 9 by 12, which has an area. Okay, anybody really quick math? Whoa, 108. Okay, has an area of 108. And so if we triple it, and now I'm going to pull this down to the end. Okay, that is 108 units squared over 12. Okay, this is now 9 times bigger. Okay, it's now 9 times bigger, and this was 4 times bigger. You'll notice that the amount that we increase the lengths, or how much we multiply the lengths by, we multiply the lengths by 2, multiply them by 3, is different from what the areas are. Okay, if we multiply the lengths by 2, the areas are 4 times bigger. If we multiply the lengths by 3, now the area is 9 times bigger. And in fact, and we're going to get to this pretty much right away, the area is the scale factor squared, okay, of the that we're using there. Okay, so whatever scale factor you're using, it's squared. So to make this rectangle here, I had a scale factor of 2 because I made it twice as big. That means 2 squared is 4. Okay, so that means the area is 4 times bigger. When we did the tripled one, okay, so that's 3 times bigger. So I multiply each side by 3. Then the area is 9, or 3 squared, which is 9 times bigger. Okay, and we're going to be taking a look at what that deals with there. But let's say that, we're going to be taking a look at it almost right away, kind of on the next video. But let's say it's halved. Okay, so if we have the size, okay, so it's 1.5 by 2. This is going to give us a area of 3. Okay, equals 3 units squared. Okay, and 3 divided by 12 is 1/4. 1/2 squared is equal to 1/4. Okay, 1/2 squared is equal to 1/4, meaning that this is how much, it's 1/4 of the size, or it's 1/4 of the size of the original.